Good evening, Dr. Katcher. Can you hear me?
Yes, I can. Can you hear me?
Yeah, I can hear you perfectly well. Thank you for taking the time to join our interview and share with our Chinese audience about your research. And it's really our honor. By the way, we've already started our live streaming and I will record our talk.
Fine.
So before we start our interview, could you please briefly introduce about yourself, maybe your company and your research views?
Okay. Myself, I spent most of my life as a professor. Uh, I became a college administrator, but my major interest was always aging. And at one point, I thought that I would. I thought that there was no way to combat aging, and ultimately, I retired. I'm 79 years old now. And about 13 years ago, I realized after reading a paper that I could cure aging. Uh, so I devoted myself to it and tried to get funding and just couldn't because my ideas kind of disagreed with the current paradigm of aging, which was that aging was like an old car wearing out. And it's just, I mean, you can replace the radiator and the mufflers and the engine, etc. But really, it was too expensive and not worth the time for nature to do. And I read a paper by a group called well, Michael and Adina Conboy, and this was out of Irv Weissman's lab at Stanford. And they conducted a process called heterochronic parabiosis, which I think in the present day would have never been allowed because it was incredibly cruel. It involves sewing two rats together such that they've shared a common blood supply. And one of the rats was old and one of them was young. This was originally tried in the 1940s by McKay. His name, his first name escapes me at the moment. Uh, who was a real leader in nutrition research, and his he had some evidence, which was uh, at that time consisted of the fact that the bones of the older rat were whiter than the bones of the older parabiotic rat, that is, were whiter than the bones of the non-parabiotic rat of the same age, which were kind of yellowed, just
Yeah.
as paper yellows with age, so the bones and tendons. Uh, a little later on, other people showed that you could actually increase the lifespan of the older rat. Uh, However, you could make the argument that, well, sure, of course, you increase the lifespan. The kidneys of the young rat are doing dual work for the old rat. The digestive system of the younger rat are digesting food for the older rat that was attached to it, etc. And clearly, you wouldn't want yourself to be sold to some old person to provide them with youth. So, but in any case, the convoys did an experiment where they showed that this rejuvenation occurred at the cellular level. Now, I was an administrator. I had no access to laboratory resources. And I read this paper 5 years after it was published, approximately. It was published in 2005. I read it in 2009. And suddenly I realized that I could restore youth in people.
Yeah, thank you, Dr. Katcher. And since our audience have already got an idea about your research and the reason why you switched your research field from maybe DNA related to aging,
Right.
and since some of our audience may only have a rough concept of blood exchanging, could you please give an overview on the blood exchanging therapy, maybe how to operate, the mechanism behind it, or is there anything
Well,
important, yeah, for our audience to know?
oh yes. Ultimately, we were going to do what's called plasma exchange. It's quite simple. Uh, there's a process called plasmapheresis, wherein and it's used commonly to get plasma from people, where you basically have a machine that withdraws the blood, spins down the blood cells, takes the plasma out, replaces it with different plasma or a solution that substitutes for plasma. In this case, the idea was to take the plasma of a young person and substitute it for the plasma of an old person and keep on doing that so that basically entirely withdrawn or almost entirely withdrawn the plasma of the old person, replace it with plasma of a young person. Now, you could see ways by which you could ethically do such a thing because people donate plasma all the time. And most of them, in fact, are young college students trying to support themselves by plasma donations. But when we actually had a volunteer, a billionaire, who would pay for this because it kind of was necessary. But at the last moment, he chickened out. I could see the fear in his eyes, and his doctor, he was 90 or 91, his doctor told him not to do it, that it was too dangerous.
Mhm.
And he didn't do it, and he died within a few months. So sadly, because he was a good guy, actually, even though he was a billionaire, uh, he made his money in education. But I don't want to talk about him. Uh, so I was out, in the wilderness, basically yelling, help me do this. This is important.
Mhm.
And I had responses basically from no one until a pair of two people came to help me. And it turned out they were phonies and they were just interested in taking money from other people supposedly to promote my research. And then I received an invitation from Akshay Sanghavi in India. I'd received one before, but I was working with these two phonies, and I told him I couldn't take up his offer. He was going to sponsor funding laboratories in the United States. But at this point, things had changed. And he said, well, I'll fund you provided you come to Mumbai, India. So at this time, I was in my early 70s, perky younger guy. And I said, sure. And my wife agreed, and my children accepted it. And I went to Mumbai and worked there for 3 years. Uh, Actually, I think it was probably more like 4 or 5 years in total.
Yeah. So,
And I just,
still needs more funding on this blood exchange study, right?
well, yeah, the funding was for the blood exchange study.
Mhm.
And instead of using mice, I used rats because they had much larger veins, but they weren't large enough. and we
Yeah.
couldn't get equipment to do this plasmapheresis. It was just not possible. We even tried doing it manually, withdrawing blood, centrifuging it, removing the plasma, replacing it with young rat plasma, injecting it into the rat. But after a very short time, the rat's veins couldn't take it anymore, and we couldn't continue without severely injuring the animal. So we stopped. And I thought that was about the end of it. But then I decided, well, let's try something else. Let's see if we can extract that portion of the blood that actually does the youthening, as I call it, reversive aging. And my ideas about that were also very different from anyone else's. People assumed it was small molecules that were responsible for promoting youth, and actually more people believed that it was small molecules that were responsible for aging. So the convoys originally wrote the work that I jumped off of, it sprang from, as it were. They thought it were substances, deleterious substances in the blood, like tumor growth factor, that caused aging. Later, other people, they didn't really pursue their work except for about a year past 2005, maybe a couple of years. And then they let go of it, and it was taken up by another person who contributed to their original work. Yeah, I'm sorry, this is a little boring, but
No, it's just I'm a little bit, yeah. No.
um,